Hey everyone! Welcome back to ZoomInData. And this is episode 28 of our KQL Concepts Deep Dive series. Today we are exploring Materialized Views, how they enable incremental aggregation, automatic query rewrite, and massive performance gains on large datasets. We are keeping everything pure concepts and interview focused. If you missed episode 27 on dynamic and bag types, it's a good foundation. Let's get started. Here is our roadmap for today. A materialized view is a pre-computed result stored persistently and updated incrementally. Incremental aggregation means only new or changed data is processed during ingest, no full rescan. Query rewrite lets the engine automatically substitute the view for matching queries on the base table when it's faster or cheaper. Benefits are huge. Sub-second responses on terabytes, dramatically lower compute cost. Limitations include storage overhead, slight latency on freshest data, and no support for deletes or updates in the view. Common use cases: real-time dashboards, frequent aggregates, high cardinality summaries, and expensive group by operations. Let's see how this magic works. Internally, a materialized view is defined as a query, usually with summarize, group by, aggregations, and saved with materialized view syntax. On ingestion, new data arrives in micro batches or streaming. Instead of rerunning the full query, KQL processes only the delta, new partitions or changed chunks, computes the incremental aggregates, and merges them into the existing view storage. The view is stored as a separate, optimized table, compressed, partitioned, indexed, with its own metadata tracking last processed time, schema, and aggregation state. This delta-only approach is what makes materialized views so efficient. No full rescans, low compute, fast updates. Query rewrite is the killer feature. When you run a query on the base table, the engine checks, does this match a materialized view definition, same filters, same grouping keys, same aggregations? If yes, it transparently rewrites the query to read from the view instead, pre-aggregated, indexed, optimized. Result: what used to take minutes on raw data now returns in seconds with tiny CPU and cost. Freshness trade-off: view lags slightly behind raw ingestion, usually seconds to minutes, but that's fine for dashboards, reports, and most monitoring use cases. The engine decides automatically. You don't rewrite your queries. Just create the view, and magic happens. Take a look at this flow and bars. They show exactly why materialized views are a game changer. On the left, your user query hits the raw table. The engine quietly checks, match view. Yes, boom. Rewrites to read the pre-aggregated view table instead. See the fast lightning and pre-AGG icon. Sub-second results, tiny compute. No, falls back to full scan, slow turtle crawling through everything. On the right, performance bars tell the story. Tall red bar for raw, slow, high cost, full re-aggregation every time. Short green bar for view, fast, low cost, pre-computed and incrementally fresh. The magic is automatic. You don't change your query. Write it against the raw table like always. If a matching materialized view exists, the engine swaps it in transparently. Minutes become seconds, expensive scans become cheap lookups. That's incremental aggregation plus query rewrite in action. Massive scale without rewriting dashboards. Incremental aggregation is the engine that powers materialized views. Supported aggregations include count, sum, AVG, min, max, decount, approximate, percentiles, anything that can be merged incrementally. KQL keeps state per group. When new data arrives, it computes delta aggregates and merges them into existing buckets. It handles out-of-order ingestion with time-based windowing, e.g., bin by hour. Limitations. View definition must be simple. No custom functions. No joins inside the view query. Joins can be outside. Best practice. Keep it to summarize by time. Key with common ags. The simpler the better for efficiency and rewrite success. Complex views still work, but incremental magic shines on straightforward patterns. Trade-offs and when to reach for materialized views. Pros: dramatic speed up, minutes to seconds, tiny compute cost, automatic query rewrite. Your existing queries just get faster. Cons: extra storage, view duplicates aggregated data, slight freshness lag, seconds, minutes, no support for deletes or updates in the view. Use materialized views when you have frequent identical or similar queries, expensive group by, summarize operations, real-time-ish dashboards or reports. Don't use for ad hoc exploratory analysis, sub-second real-time requirements, or tables with heavy deletes. Classic pattern: ingest to raw table, then materialized view computes aggregates incrementally. Next dashboard queries hit the view. Fast, cheap, scalable. Materialized views are one of KQL's biggest performance superpowers for production workloads. Look at this balance scale. It sums up exactly when and why to use materialized views in KQL. On the left pan, pros: lightning bolt for blazing query speed, low compute icon because incremental updates cost almost nothing, auto rewrite checkmark for transparent magic, and green reliability check. These views turn expensive, slow queries into sub-second responses with minimal CPU. Perfect win. On the right pan, cons: storage $sign because the view duplicates aggregated data, clock for freshness lag, seconds to minutes behind raw, no delete icon since updates, deletes aren't supported, and warning triangle for potential gotchas. The middle arrow says use for frequent, expensive queries, and it's tipping hard toward the pros. If you have the same summarize or group by running over and over, dashboards, monitoring, reports, the speed and cost savings far outweigh the extra storage and slight lag. But skip mat views for ad hoc exploration or tables with heavy deletes. They're not a fit everywhere. Bottom line, materialized views are a production superpower for repetitive, costly aggregates. Create them thoughtfully, monitor storage, accept the tiny freshness trade-off, and watch your dashboards fly while compute bills drop. Why does this topic matter in interviews? Materialized views are one of the top KQL performance features. Interviewers love asking about them. Common questions include: how do materialized views work incrementally? Explain query rewrite. When would you create a materialized view? Understanding incremental aggregation and automatic rewrite shows deep production scale knowledge. It's critical for observability, monitoring, and by dashboard roles. Explaining trade-offs. Extra storage for massive speed gains demonstrates pragmatic thinking. If you can say, I create a mat view on daily summaries with bin, timestamp, 1D, and common ags, then dashboards hit the view instead of raw logs, you sound like someone who's optimized real clusters. To wrap up, a materialized view is a pre-computed, incrementally updated aggregate stored persistently. Incremental aggregation processes only new data on ingest. Delta merge into existing state. Query rewrite lets the engine automatically substitute the view for matching queries on the base table. Transparent performance boost. Benefits: seconds instead of minutes. Tiny compute cost. Trade-offs: extra storage, slight freshness lag, no deletes. Use materialized views for frequent or expensive aggregates, especially time-based summaries, dashboards, monitoring. Create them on the raw table, let ingestion keep them fresh, and watch your queries fly. This is one of KQL's most powerful features for production-scale analytics. That's episode 28 done. Thanks for spending time with me on ZoomInData. Next in episode 29, Approximate Aggregations Deep Dive, we will explore T-Digest for percentiles, Hyperlog for counts, CountMin sketch for frequencies, and when to choose approximate over exact. Homework to lock this in. Explain to someone or out loud. What is query rewrite in materialized views? Think of a dashboard query that would benefit from a materialized view, e.g., daily error counts. Answer this one. Why is incremental aggregation more efficient than full rescan? If this helped, like the video, share it with anyone prepping for Azure interviews, subscribe for episode 29, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those concepts. Bye for now.